So isomers are when the atoms are connected in a different order. Resonance structures are when some electrons are delocalized, which when you're drawing the Lewis dot structures, that means that it appears that the double bond can be in two different equivalent places, but know that it is actually that those electrons that make up that second bond are delocalized. They're being shared by more than two atoms is what's happening. So let's just look at an example. So you know that you have resonance when you're drawing a structure, and you have to make a double bond, but there's more than one place to make an equivalent double bond. So for example, in this molecule, this is ozone. When I get to this point and I have all of my electrons on, I see that my central atom does not have enough. It has 2, 4, 6 around the central atom. So I'm going to move in a pair to make a double bond. And when I did that, I chose this oxygen. So I could also choose the other one, and I need to draw that structure, choosing the other one. To make the double bond there. And so then I'll draw a double arrow between them. We call these resonance structures. This molecule has 2 resonance structures, and what's really happening is that pink or orange, the colored electrons, there's 2 electrons there. Those electrons are actually being shared by all 3 atoms. We say they're delocalized. They're not stuck between 2. The last thing is just kind of going through the different geometries that you will see. So Lewis dot structures, be sure you start with your electrons. Make your skeleton, add electrons to the outside atoms first. Only make a double or triple bond if you have to get an octet. After you do that, you need to count your electron groups. And when I count electron groups, I don't usually go through and count how many are lone and bonding. I just go from electron groups to how many atoms. So just to show you what to do with those, if you're asked that, this top one is basically a 2-atom molecule. And if it's a 2-atom molecule, it doesn't really make sense to talk about the electron geometry because you don't have a central atom. But we'll just, you can just say that these don't really make sense because it's, there's no central atom. So, but we'll call it linear, so it's linear. Then these with 3 electron groups, you know, will be trigonal planar. That's when you have a central atom and then like that coming out. And then if you have one with bonded to 3 atoms, then the molecular geometry, so I'd have 3 atoms bonded, the molecular geometry will also be trigonal planar. If I have just 2 bonding groups, that means there will be 2 atoms bonded. I just saw I didn't put, let's put the 3 there. Okay, and on this one there's electrons there, but it's a lone pair. And when we do the models, we just put a stick there so that you can see that there's a lone pair. But with 2 bonding groups, 2 atoms bonded, the electron geometry is still trigonal planar, but the shape is going to be bent 120 degrees. And then on these with 4 electron groups, these are all going to be tetrahedral for their electron geometry. And then on this, bonding groups will have 4 atoms, 3 bonding groups will have 3 atoms, 2 will have 2 atoms, and then we have our geometries, our molecular geometries will be tetrahedral. This one will be trigonal, but this time pyramidal. And this last one will be bent, and this is the 109.5 degree bent. So here's tetrahedral. There's the trigonal pyramidal. And we could call this the bent.